Next up, we are going to solve the following 2 by 3 system. That's a system of 2 equations with 3 variables. First equation is x1 minus 2x2 plus 5x3 is equal to 2. And second equation, 3x1 plus 2x2 minus x3, that's going to be equal to negative 2. Now, something that should be said when you have more variables than equations is that it is impossible for this to be a consistent system. We are guaranteed to get either an inconsistent system or a dependent system. Now, getting an inconsistent system would happen very straightforward. We would see that these two expressions on the left-hand side would be multiples of one another. So what we're going to try to do instead is start eliminating some of the variables to get it into what we referred to as row echelon form from the earlier video. I want to see if I can eliminate the x1 variable from the second equation. Now the way that I'm going to do so is I'm going to take equation number 1, multiply it by negative 3, and then just recopy equation number 2, and then perform our elimination addition, similar to what we saw in the previous video. Multiplying the first equation by negative 3, we arrive at negative 3x1 plus 6x2 minus 15x3. That's going to be equal to negative 6. Next, I'm going to add these two equations together to see what we get. The x1 variables are eliminated. We get 8 times x2 minus 16 times x3 is equal to negative 8. Now this by itself would do okay for us, but what I'm going to recommend that we do is get a lead coefficient of 1. We can do so by dividing both sides by 8 and arriving at x2 minus 2x3 is equal to negative 1. In this regard, we can treat our system of equations as x1 minus x2 plus 5x3 is equal to 2, and the second equation as x2 minus 2x3 is equal to negative 1. We get our nice little row echelon form, and now we can identify that x1 and x2 are now both lead variables. Excuse me. This also means that x3 will be our free variable. Excuse me. As such, we will let x3 be equal to a parameter. We'll call it t. From the second equation, this means that x2 minus 2t is equal to negative 1. We can now solve for x2 in terms of our parameter. x2, therefore, will be equal to 2t minus 1. Now we can take both x3 is equal to t and x2 is equal to 2t minus 1 and plug those into the first equation in an attempt to solve for x1. So x1 minus 2 times, formerly known as x2, that'll be 2t minus 1, plus 5 times t is equal to 2. This is going to require some algebraic manipulation, so let's do so. We'll start by distributing the minus 2. We'll get minus 4t plus 2, and then plus 5t, and this is all equal to 2. Combining the t's and subtracting the 2's, and then subtracting what we get when we combine like terms, I believe we are going to wind up with x1 is equal to negative t. x1 plus t is equal to 0. Yep, x1 is equal to negative t. So the solution for this system is going to be the set of all ordered triples of the form negative t, 2t minus 1, and t, where t represents any real number. We would refer to this type of system as being dependent, since it has an infinite number of solutions.